Okay, so let's go on to the next question about volumes of gases. So, so we're reacting ethane with oxygen to make carbon dioxide and water, and they've told us that we have 20 centimeters cubed of ethane, 100 of oxygen. Now, whenever you have questions like these, and this is common for multiple choice, what we want to do is we want to compare we want to consider that the volumes are going to be like moles, and the reason behind that is because we know that one equation for finding volume of a gas is using moles is equal to a volume over 24, and if you see here that it's basically moles is proportional to volume. It's basically a constant 1 over 24 times volume. So if you can just make that a constant, that means moles is proportional to volume. So you don't have to do any fancy calculations and turn it into moles first. We'll just straight away use the volume as if they were moles. Okay. Now the question is, if you're reacting 1 mole of this with 3.5 moles of oxygen, you want to know which one will finish first. So to do that, we're going to first of all make the molar ratios equal to each other. So for example, we're going to times the ethane by 3.5. So that means this will also become 3.5, just like that. So now that means I'm going to, if I have 100 centimeters cubed of oxygen, I will react 70 centimeters cubed of ethane with that. Okay, so that means now from these two, obviously ethane is the limiting reactant. So ethane falls to 0, the 100 will fall to 30, because 100 take away 70 is 30. Okay, so ethane's finished. Of course, oxygen drops to 30, but also because these two reacted, we made some products. Again, to find out how much products we made, we compare it with the limiting reactant. So again, ethane to carbon dioxide and water, it's a 1 to 2 and a 1 to 3 ratio. So we're going to times the numbers by 2 and 3. So 20 times 2 gives you 40, and 20 times 3 gives you 60. So that's how much carbon dioxide and water have been produced. Finally, if we add all three of these together, so you have 30 plus 40 plus 60, that's the total amount of gas remaining at the end of the reaction, which of course adds up to 130, which is the answer. Okay, next question. So we have Freon, which is CF3Cl. We have 1.78 times 10 to the minus 4 kilograms of Freon, which is a gas, and this gas has gone into a room which has a volume of 100 meters cubed. Now, we want to know how many particles there are. So remember, to find number of particles, we just do moles times Avogadro's constant. So to find that, what we're going to do is, number one, we're going to work out number of moles. So again, moles is easy, mass over molar mass. So we're going to convert this into grams first. So that becomes 0.78 grams. And then divided by the MR of Freon. So that should give you this number of moles. Okay. Now this is the number of moles in 100 meters cubed. But what the question wants from us is how much particles are there in 500 centimeters cubed. So not in the whole room, but just in 0.5 decimeters cubed of the room. So what we're going to do is convert this, which is for 100 meters cubed moles. We want to know how many moles are going to be in 0.5 dm cubed. So all we have to do is first do this calculation to turn meters cubed into decimeters cubed. So if you have this much in 100 meters cubed, we're going to have 1,000 times less in 100 decimeters cubed. After that, we are going to then convert that into 0.5 dm cubed, so divided by 200. So this number right here is how many moles of Freon gas we have in 0.5 dm cubed, which is what they want us to know. But they don't want us to tell how many moles we have. They want us to say how many particles there are. So to find particles, we're going to do moles times Avogadro's constant. Okay, so once you got that, just plug that number into here, times it by Avogadro's constant, and you should get this many number of particles in 0.5 dm cubed. Okay, and then final question, we have hydrochloric acid 5 centimeters cubed with a concentration of 0.01 mole per dm cubed. The student adds water to it, so an X amount of water is added, and the final concentration after adding water, after diluting it, should be 0.0005. But the question is, how much water do we have to add? Now this obviously is a dilution question. With dilutions, because we're adding water, the number of moles are not changing. So the number of moles before and the number of moles after are the same. So whenever that happens, we can use a formula called C1V1 equals C2V2. So C1V1 is the initial concentration and volume, and C2V2 is the final concentration and volume. So of course, we don't know what the final volume is going to be because we don't know how much water has been added. So that's why we use this equation to work it out. So we're going to work out a V2. So V2 is going to be, of course, plug in your values, and you get 100 centimeters cubed. So that means this solution will have a volume of, this orange one, the final one, has a volume of 100 centimeters cubed. So the question is not saying what the volume is, it's saying how much water do we add to the red one to get to this final. Now it's already got 5 centimeters cubed already, so to get to 100, all we have to do is add 95 more. And I hope that has answered your questions. All the best with your exams.